All right, let's get cooking. This is Firewall, Evasion, and Remote Access with OpenSSH. That's me. I'm Anthony Nocentino. I'm a consultant and trainer, founder of Nocentino Systems. Data Platform MVP, which is kind of unique in this community, I guess. Linux Foundation certified engineer, and I have some contact info. Actually contact me. A lot of you guys I know, or you all I know, have reached out to me on Twitter and such, but there's my data. But if you have any questions, feel free to ask. And so we're gonna jump in right away because this is gonna be a lot of content. We're gonna go fast, but do ask questions. We're gonna do lots and lots of demos and showing you how to do these things, and you'll get both the scripts and the presentations when we're done. And so we're gonna start off with a quick background on OpenSSH, just how it works, how things move around, some of the key benefits, why we would use it. Who was in my session last year on OpenSSH? Cool, okay. So basically I took one of the bullet points from that session last year and just went a whole level deeper. And so we're gonna go there, but don't feel like you needed to have been in last year's session to be here today. This is totally independent, but I do encourage you to watch last year's session to kind of fill in some of the core concepts behind the scenes. And so I broke this into two chunks. We're gonna talk about accessing resources and then accessing networks. And so we're gonna start off with accessing resources, like stuff, right? Like applications. We're gonna start off with how to access basically HTTP servers through what's called a dynamic port forwarding proxy, which allows us to basically send data through something else and go get stuff from somewhere else, and it's really cool. Then we're gonna do kind of I think like the de facto standard for port forwarding, this concept called local port forwarding, where we basically inject traffic into a local port, ship it somewhere else over a tunnel, and it pops out, and we go access something on another device. This one's pretty trippy. Who's worked with reverse port forwarding before? This is crazy, right? You're gonna see this and you're like, really? People can do this? And people like don't protect against it? And oh yeah, we'll talk about how to protect against it later. And then also, this is kind of key. And most of these will actually, one of the nexuses behind this conversation is who has servers in the cloud today? Like actually like stuff that you're managing in the cloud and has like a jump box and all that fun stuff. You have to deal with the fact that we have like this disconnected world. Well, I'm over here and my stuff's over there. Well, guess what? You can make an SSH connection directly all the way through as if you were on that local LAN with what's called a jump host or a multi-hop proxy. And so we'll look pretty closely at how that works. Then we'll talk about accessing remote networks. And so all of the stuff that we started at this top half is application level. We're gonna access arbitrary TCP services, web servers, things like that. But with SSH, we can actually tunnel raw IP, which is crazy, right? We can stand up a VPN between two locations and send traffic through. How many people have security administrators that be sad about that? Right? And by the end of today, with like 6 lines of code, you're gonna be like, wow, that's cool, right? And so, oh yeah, SSH VPNs. But we do, for that one specifically, oh wait, I don't wanna let the cat out of the bag yet, so I'll tell you later. But there are ways that we can protect against this. And some of the default settings, actually, we'll have to make modifications to those to enable some of these features. But you'll be surprised at how little we have to actually change to do all of these things. In fact, there's only one setting we have to change in the default SSH daemon to make this stuff happen, right? Which is bananas. Out of the box, you can do these things. And so let's do kind of the basic stuff first, kind of overview of what SSH is, because it's just for remote terminal access, right? I can just execute commands and walk away, right? No, there's a lot more. So SSH has been around for a long time. It's basically the way you access Linux systems over the network, right? Even if they're like right over there. I mean, I'm lazy, I'll walk over there and I'll SSH into that. So we get secure client to server communication. Basically, this combination of both asymmetric and symmetric encryption pretty much makes the data stream, I don't want to say impenetrable because that's not like a thing, but it's pretty close when you have symmetric encryption and a securely exchanged key. Remote command execution, we can do this with SSH. So the concept of like invoke command, which you all might be used to, well, we can do that in SSH. It's a lot fancier though in PowerShell. So I'll give you guys props for that one. In this case, when we execute commands over SSH, you just get back stuff over standard out, which means there's some stuff that you have to do to make the magic happen there. Secure file copy is probably one of the most commonly used features. I can arbitrarily copy a chunk of data from me to you, no big deal if I can connect to you. And over the internet, over what it is, do that securely and very, very quickly. This one is the one we're gonna spend most of our time on today. So this is actually the bullet point list of things that I covered last year in my session, but we're gonna focus primarily on this today because I thought it'd be a good thing to go to the next level. of what we can do with SSH. And then this is a big deal, integrity, right? I need to be able to make sure that the system that I'm talking to is the system that I'm talking to. So there's a key exchange method behind the scenes that validates who I am talking to is the machine that I think it is. And if something went wonky with the key exchange, SSH will tell me, and I want to be able to react. So in that sense, watch last year's session for a deeper dive on that. And then message integrity, this is key. With SSH, the stuff that I put in on one side of the fence, when it pops out on the other side of the fence, I need it to be the exact same. And so SSH facilitates for that. So I can exchange data securely, and I can exchange data and make sure that what I sent over the wire is what popped out on the other end of the wire. If that changes, that's a bad day. Why do we want to talk about SSH? Because it is the transport layer for PowerShell core remoting, right? In this cross-platform heterogeneous world, we get this, and we can talk to pretty much any system we want when it comes to using PowerShell remoting and PowerShell core over SSH. Has there been any movement on WinRM or WinRM-like capabilities on the Linux side of the house since last year? I haven't really looked into it. Does anybody know? No? Yeah. Yeah. Okay. Cool.
We're just happy to have it.
All right. Cool. All right. So let's get into the first one. So that was kind of the background-y stuff. And let's do some stuff. So access to remote resources, no one's going to suspect anything. In fact, no one's going to know. They're just going to see an SSH tunnel that you built, which usually is an alarm in itself if I see like a large data stream of SSH on the way out. So use this sparingly. I'm having like flashbacks all the time, so I'm getting yelled at work for doing stuff like this. So, all right, okay, rolling on my sleeves, it's about to get dirty. So proxying with dynamic port forwarding. This is going to be the scenario where I want to have application level forwarding, leveraging what's called a SOCKS proxy. Who's gone into their web browser and configured a proxy server before, right? Well, we're going to do that, but we're going to do that with sending our traffic over an SSH tunnel, basically to emulate like we're coming from another host on our network, right? And so let's kind of look at this visually and how it really lays out. So let's say I am on a machine somewhere, right? This one here maybe, I don't know. And I have some machine somewhere else, maybe like in the cloud, maybe in a data center somewhere else, or like on a more trusted segment in the network or untrusted segment. I can build a tunnel to that host, and anything, and then declare that I want to enable what's called dynamic port forwarding. So SSH-D for dynamic port forwarding. I then specify a port, 8080, and I authenticate to that host, that remote host. What that's going to do is open a local socket on this local machine here. Now, I can use any web browser, point it to that socket as a SOCKS proxy, and connect to an arbitrary host on the network, however I want to do. Yeah, however I want to move forward. And this is pretty valuable because now anything that I access externally is going to look like it comes from that host in the middle, right? Which means if I need to access something on a secure network, I can look like I'm on that network. And so this is also valuable if this host here doesn't have access to any network, right? This thing could actually not even have a default route. As long as I can touch that host, I can then route my traffic through there. So similar concepts to application proxies or perimeter proxies that you might have used in your network, but you're doing this on your own. When I was in grad school, I was older, I was like 27 when I was in grad school, and I lived off campus, but when you were on campus, you could stream baseball games for the university. I went to Ole Miss, so you could watch Ole Miss baseball games online for free if you lived on campus. And I lived off campus, and I managed a cluster of Linux servers on campus, and you can imagine what I did to watch Ole Miss baseball games for free when I was at home, right? So I could access trusted segments, very like those times where like those research libraries that can only are available from the library on campus. Maybe I didn't have to go to the library on campus to get access to those things, right? But I mean, jokingly, but you can see like this is the stuff that we can do with this very, very simple technique here, right? Or you could put something in Azure and access a resource in Azure, which is what we're going to do in a demo today. So accessing internet resources from trusted segments, the concept of getting access to a resource that might only be allowed access to from a particular resource, like Ole Miss baseball games on campus. Or, I think I touched on this a second ago, on trusted segments from a remote server. And so let's do this. I think this is more impactful when we see it in person. So I have these scripts here. I'm going to give them to you guys. And in the scripts, rather than have it be sprinkled with, if you could see the scripts, that would be helpful. I was talking about how awesome that touch bar thing was when I started. Not so awesome right now. Let's see. System preferences, displays, arrangement mirrors. How's that, team? Is that better? Awesome. All right. So you're going to get this script. It's written primarily in Bash, but with this conceptually would work on Windows as well. I didn't QA this on Windows. It works on Bash on Linux. So rather than have IPs sprinkled throughout this, I'm going to use environment variables so that you can kind of see, like, am I on this VM, am I on that VM? And this jives with the pictures in the presentation portion of the course. So you'll be able to know who's what and where. So local VM is actually a local VM on my system. So now when I run that code on the top, we see that it pops out the output on the bottom. So here, you can see I'm logged in the local VM. And so I have an Azure server that we're going to use, which is going to function as that middle box in the diagram that we just looked at. And that server lives here on that IP, conference Wi-Fi. Awesome, cool. And so let's go ahead and log out of that. And we're going to start off with SSH proxy. So we're going to do the most basic configuration. So SSH minus capital D, case sensitive, it cares. 88 is going to open a local socket and connect to. So what you notice here is it actually opens a remote terminal. And so I have to go and open another terminal to connect, to leverage what I just did there. So I opened up that proxy. I'm going to connect back into another local VM real quick. And I'm going to show you, we use netstat minus plant, which is easily one of my favorite commands on a Linux operating system. And it gives me this wonderful output here. And you can see that I have a local socket open on 8080 listening from SSH, the process 1232, right? So with that now, I'm going to use curl. Who's used curl before? Oh, yes. All right. Don't have to explain it. It's a command line web browser. It's awesome. And I'm going to hit this website, which I found the other day. It's probably got malware or whatever. Luckily, it's on a VM. But it tells me what my external IP is. So on conference Wi-Fi, that's my public address, right? So I'm accessing resources on the internet. That's what I look like. But if I want to change that very easily, I can say curl, specify the proxy type. In this case, it's going to be SOCKS. I'm going to send traffic into localhost 8080. And I'm going to access that resource. And so this is just a parameter of curl that we define. It's no different than going into Chrome and setting your proxy server or into IE or whatever is Microsoft is using nowadays, and access that thing, and then boom, look, I am now that server in Azure, right? Which is pretty crazy. Now I can do this and jump around, access resources based on whatever security I want to circumvent in that circumstance. So in that case, you noticed I had to create a second session, right? Because that first terminal window that I created logged into remote VM. So I had to go and create a second SSH session. Who knows you could do that in VS Code? Isn't that awesome to have two sessions at the same time? I like that. So let's go ahead and get out of this one. I'm back on remote VM. I'm going to get out of remote VM. And with this crazy combination of stuff, which I've documented for you guys here, so we can do things like add compression, attach the standard in, background our SSH process. Don't execute any command, dynamic port forwarding. What that gives us this ability to do is this. So now I opened the session, and now I'm still on this host locally. So now I don't have to have that second bash prompt to go about those things. All the same stuff applies from a second ago. And I can go and do the things that we just did. But that thing's up as a background process, and I have to go ahead and kill it when I'm done. Easiest way to do is to kill all SSH, which will actually kill all of your SSH sessions, so your mileage may vary. But in this case, I have only one open. And so if I go back and I do this, then I'm in time wait, which is a final TCP state, but that is not an open connection anymore like it was before when it was in the state listening. Cool. Is that fine? Yeah? Easy too, like one parameter. That's all you need. So tunneling with local port forwarding. This is kind of like the first step in doing things your network administrators don't like. And so tunneling with local port forwarding gives us the ability to use a local socket to forward traffic to a remote host. Maybe there's like an insecure service that I didn't want to open up on a firewall, and I can go ahead and access that service through an SSH tunnel, And so let's see what that looks like graphically. So again, we're going to have a local SSH client here, which is going to be my laptop. We're going to have a remote server in Azure. I'm going to have a web server running on that server, but I'm going to have a network security group around the whole network, and I can't touch that thing, right? But we're going to be able to touch that thing that is that web server in a second. And we can do that with this. So SSH-L for local fort forwarding. That's a thing. No one tweet that, which, right, inversely means that everyone tweets that. So 4321 is the local socket at which I'm going to send traffic to. Oh, so yeah, so we're going to build a session. 4321 is a local socket we're going to send traffic into. And the local host is what's called a bind host, is what is bound to locally. You saw a second ago, listen was bound to 127.0.0.1, right, local host, which means no one else on the network can touch it, just us. But there are scenarios where we can change that and actually have that bind to the real IP on the network, which means other people could use this. That's fun, right? So I can then tunnel my traffic through port 22 to get access to that service over the network, right? Even if there's a firewall blocking that on this machine, even on a local machine, if there's a firewall on that host, as long as I can get through 22, I can send any TCP socket or name socket as well through, right? Bananas. So in this, yeah, name sockets, accessing less secure applications. So this, the nexus of this, if you go Google it, you'll see a bajillion articles about tunneling things like VNC and RDP and things like that. So, and obviously we talked about getting around network-based firewall rules and host-based firewall rules. It's like I'm getting ahead of myself. Coffee? Anyone? I actually had tea before this session too. All right, so let's do this thing. So in this case, I'm using the Azure CLI. Say, hey, Azure CLI, what are the firewall rules you have? I have only one. That is an inbound rule for port 22, right? And I want to go and access an application that lives on that machine, right? But I can't because of the network security rule. Who's familiar with network security groups in Azure? Cool, it's basically a perimeter firewall around your VNet where all your stuff lives. So like basically, no different than I guess a perimeter firewall conceptually that you'd have on-prem. But it's defined in software in Azure in the cloud. And so let's go ahead and double check, because we're good network folks, and we want to make sure that we're actually running the web service, because who wants to get involved in a troubleshooting scenario when like you're trying to access a web server that's not actually online? Let's make sure it's online, and it's on. It is. So we see it's on port 80. It's listening on all IP, and that's the HTTP server that's running on that remote host in Azure, the box on the right in the picture that we looked at a second ago. So let's go ahead and exit out of here. We are logged out. We're back on local VM. I'm going to build that tunnel. So I'm going to say SSH-L 4321, arbitrary port. Anything above 1024 on Linux is fair game. Below 1024, you need to have privileged access, basically root. Is that concept that exists in Windows, where below 1024 is privileged? So yeah, so in this case, on Windows or on Linux machines, you want to be above 1024. On Windows machines, see what happens. So there we go. So I have local port forwarding enabled. Again, in this case, I have to open another window because it logged me into remote VM. So I'm going to go ahead and open that up, another window, run this code, get onto local VM, double check that I have what I want. To see if I'm listening, I am. So now, from local VM, I can access that web server and get through the NSG and touch that web server, right? Pretty cool. Again, one line of code, and I didn't change any configurations on anything. So let's go ahead and back out of there. Uh-oh. Why are you? One more exit. Okay. Now, what if we want our console back? And I don't want to have to juggle multiple windows. And this is a little bit different than the scenario a second ago. So we add SSH-F to fork a process, and then -L for the local port forwarding. And we specify that our local bind port is going to be localhost, and the app that we want to forward to is 80. So it's got to run that. But it's like, why? I need a process to fork. Okay. So we have to fork a process. In this case, we're going to feed it the sleep process for 10 seconds. And this is cool when you want to access something like VNC or RDP. So it brings the tunnel up, sleeps for 10 seconds, and then shuts the tunnel down. But if I come along and I attach to it, then the sleep will hang, and I'll be able to hold the connection up, right? But in this scenario, I probably didn't hit it. Oh, I did hit it in time. But if I wait, it's going to fail because it's sleeping for 10 seconds. This is kind of the standard way to bring it up real quick and then let it come down when you log out, right? So, and then, yeah, if we want to, let me bring it back up so we can see. And that's going to be that. So we're listening on 4321. I told you it was my favorite command. That's that minus plant. All right, let's keep cooking. So reverse port forwarding, this one's trippy. And I think you'll probably get the most mileage out of this one, honestly. So remote port or traffic forwarding is forwarded back to the local host over SSH. And so let's look at what that really looks like. So in this scenario, I have an app server and I have an app client. And let's say that this is something that I'm working on. Maybe I'm debugging an application. I just want to expose something on this to over there. And there's a network boundary between me and that thing, and I can't open ports or connections in any way. Well, except an outbound SSH connection. And so I could say SSH-R, localhost. On this one, I'm going to bind the 4321. So that'll open that on that side of the fence. And then I can tunnel back through and access anything on this side of the fence. So whatever I want to put at port 80, it can then come back through. And so this is crazy because I can not have a public IP. I cannot have anything open to the internet. And this machine in Azure, in some data center, wherever it is, can come back and access any port resource on this machine here over SSH, and nobody knows. Yeah, so accessing resources from remote segments, we can evade firewalls, and that remote port can be any TCP socket. In this case, remote's actually on this side. You're supposed to ask the really engaging questions.
Google.
All right. What was that? So the difference between a socket and a port in Linux everything's a file. So I can bind to a port, but I could also bind to a file location, which would be a socket on the system. So it's just a different construct that I exchange data between the OS and the network to get it through to a device. So let's do that one. So we're going to do SSH-R. This is going to be remote reverse port forwarding. So SSH-R, we're going to bind to localhost 4321 80. It's going to run that there. In this case, I don't mind that it goes into the remote terminal, where before I had to either go around it or use -F, and because I would get logged into it. But now I want to go from that server back into my server. So I'm in Azure right now, and I have a web server running on my laptop. Let's make sure. So there's our port. And now that web server that is running on this machine here, which over conference Wi-Fi I just accessed back into here, right? Which is pretty bananas because I can use, it's not a reverse local proxy, it's a reverse port forwarding. So I will update that for you guys. Cool. No? Man, I thought that would be way more dramatic. Anyway, so do you want Josh or Joshua? All right, we're buddies on Twitter, and we had this conversation a couple of days ago. This is crazy. I think we're going to go through what's called a multi-hop jump box, right? Which allows your SSH connection to be able to pass through a host. So I can have this scenario: my laptop, intermediate host, protected host. I use that sequence -J, and it's going to be the remote, this one server name, and then private's server name. Or login, excuse me. And I can do this. And I'll have a direct SSH connection all the way over to here. And so usually we do this, right? We SSH to the one thing, and then we SSH to the other thing. And then there's kind of a disconnect, right, between the local machine and the private machine. But in this case, nope, straight through. And so let's go ahead and do that together. Yeah, so accessing a protected host through a server, evading firewall rules, all the nasty stuff. And this, on the private side, doesn't even have to be reachable, routable from the internet. It couldn't even have a default route. It just has to be able to touch this machine here, right? Be reachable from that system. And so let's go ahead and do that together. Yes. Oh, thank goodness. Okay, what do you got?
So the stuff you talked about before with the port forwarding, can you do that across the multi-hop jump host? Do like a
Combine the two? Honestly, I would not be surprised if you can. Oh, the question is, can I combine these other techniques with this technique? I see no reason why not to. I haven't tested it, but knowing how the stuff's all laid out internally, I have no reason to think that we couldn't. Yeah. Right. So, all right, so I'm still on local VM, and I'm going to SSH into remote VM. I'm going to do this the old school way, and then I'm going to SSH into private VM, right? So hop, hop, and then that's two completely independent connections. So I have to exit, exit. Now I'm back on local VM. But I can combine the two like this. I can just say, hey, I'm going to access private VM directly with SSH-J. I'm going to give it my login information to the remote VM, which is the intermediate host that would be in the middle, and then private VM, which is going to be on the far right in Azure. Doesn't even have, yes, so let's go do that. Oops, I exit it right away. Who let this guy in? And so I slid all the way through to server 2, right? That's crazy. All right, you guys ready for this? We can combine a couple of techniques here. So I'm using what's called a .ssh config, where I can specify all the techniques that I've been working with so far in a configuration and address them as aliases, right? So I don't have to like get in the business of like typing all these parameters and ports and all that fun stuff. I can just go ahead and call the alias by name, which will be this, and then leverage that. And so we're gonna use this last one here, host jumpbox, username. I'm going to define the host name of the system that I want to connect to, which is the private IP in Azure, and then the jump box, which is the one in the middle of the picture that we talked about. I'm going to launch PowerShell, because, you know, I think I have to at a PowerShell conference, at least once. Enter PS session, host jump box, boom, slid right through, and I have a PowerShell session to that private host, right? And the only, so I do have, I did have to install PowerShell core and configure the SSH subsystem on that inside of PowerShell, but that's pretty cool, right? So now all the skills, thank you. So now all the things that you're used to using, you can leverage in this case and don't even have to put your servers on the internet anymore. Well, one of them has to be on the internet. And in that sense, you could do things like multi-factor authentication, tokens. Right. And all right, so the funny thing is, this can keep going. There's no limit on the number of hosts that I can put. I'm sure there's a practical limit, but I can just keep adding and jumping and jumping and jumping and jumping. Yeah. And so now in this sense, I have it laid out for you guys, or for everyone, on how you authenticate. If you notice, I'm not typing any passwords or anything because I'm like super lazy in that sense, but I'm using a public and private key pair. That isn't password protected, so I'm using what's called keyless or passwordless authentication with public and private keys. In this case, I have to have my public and private key pair on my box and the intermediate box, because that intermediate box is going to do a second login to the private box, the one that was all the way on the inside. And that was actually, it's taking two separate connections and bolting them together inside of SSH. So it's a whole new login, but it's a single stream through. Let's find out. So there's a couple ways we can go about looking at this. How are we doing on time? Okay, yeah, we're good. Who types during demos? So this is on server 2. And so yeah, so it sees the TCP session is established from the intermediate host. Yeah, because it's 2, right? So it's a brand new connection, but the magic is happening by SSH basically sending the traffic through for me. Oh, there's a system call that does that. It's like right here. All right, I'll try to remember. But there's a system call that takes 2 connections. Clone? I think it might be clone. All right, that's another day. For TCP sockets, it's going to be within that. So the comment was T. Conceptually, yes, very similar conceptually, but in implementation, slightly different. So, all right, so we talked a lot about apps so far, right? SOCKS proxies, arbitrary TCP applications, and things like that. Well, now we're going to go to the next level and basically connect IP networks, which I think is going to be fun. And so this is going to be relatively straightforward and not a lot of commands to make this magic happen. So we have the local system, my box here, that server in Azure that we're working with. I have 2 network segments on each side of the fence. And we're going to create 2 tunnel interfaces, which this will require system level or privileged an operation to create an interface on these two Linux boxes, right? And we're gonna have to IP them and create routes. And so this requires privileged access. And we're gonna create a connection between the two. We're gonna use -F to fork it to the background, -W, because I guess they probably ran out of letters because V was taken. And that -W is going to say, let's use this tunnel interface 0 and that tunnel interface 0 and make basically a VPN tunnel between the two, right? If you did ton 1, it would be 1. You know, if you did ton 2 on the right, it'd be 1:2. So those are just interface indexes. And so let's go ahead and do this. Oh yeah, and we need routes. And so to make this really work, then we get like into network engineering, right? We can build this tunnel and we can move arbitrary IP between the two, but then we have to like route things and do all that fun stuff. But if you're motivated to do things, you will do things. And so let's go ahead and do that together. This is surprisingly not a lot of code. In this scenario, so I'm gonna go into a remote VM for a second, and we're gonna go and I'm gonna show you the only thing that you have to change in this connection, so permit ton, goes from no to yes, right? In SSH, this is the, I kind of jumped over a little bit, but this is the SSHD configuration. So this is the configuration file for the SSH daemon. On Windows, it's identical. The team did a great job in the port that they did for Windows, so the config files on the Win32 port are identical. But like I said, I didn't QA my demos against Windows. I did this against Linux. But you're only minutes away in Azure from a Linux VM, right? So when you're reading the SSHD config, anything with a hash mark in front of it, if you're using the default configuration, is going to be comments, and this is the default value. That's kind of just the convention that the team uses that maintains OpenSSH. And so when I make configuration changes, I always leave the default there, and then I just put a new line and whatever I change right below it. In this case, I just switched it to yes, right? All right, who was in my session again last year? About 10 of you guys. Why didn't I get logged out right there? So it said that keeps the session open when it starts the service. So what happens when you log in, the service that's exposed is a minimal set of code in SSH. So port 20 is basically enough to hold open the connection and fork a separate process. And so that's an entirely separate process in its own process tree if I kill this process. It's not a child process anymore. And so the SSH daemon forks that second process. I can restart this, and this will get rebased off of PID1 or my session. And so I'm able to keep my SSH session open. This is really valuable, actually, when you make configuration changes. So go open a session, park it in the corner, make a daemon change, bump it. If you can't open a new connection, don't let go of that one, right? But it's a pretty good technique. And the reason for that isn't convenience. The reason for that is because the SSH daemon itself, they want to have a minimal set of code exposed to the actual internet. So let's do this. So this is some network stuff that we're going to basically create a device. So we're going to use the IP commands. We're going to add a tunnel interface, add device ton 0 mode ton. Again, working under the assumption that you have privileged access here. Then I have to give that interface some IPs. I love VS Code for demos. You get that highlighting right there so you can see everything, how it kind of relates together. So the device is going to get an IP, and it's going to also get a route to the tunnel. This is going to be my local address of the tunnel. This is going to be my remote address of my tunnel. And so let's go ahead and, I did add. Let's go ahead and create the interface. Let's go ahead and create the route and enable routing. This is the Linux systemctl command to enable port forwarding. Too much port forwarding today. Enable IP forwarding between interfaces. So now on the remote side of the house, this was on local VM. Same stuff, but I'm going to invert the IPs, right? Because I'm going to go to 1 to 1 and 2 to 2, or 1 to 2 and 2 to 1. Let's go ahead and run that. Give that a route. This is my local IP segment. This is my Azure VNet. Exit, back on local VM. So I'm on this laptop with no internet connection, or no public IP connecting to remote VM in Azure public IP. And now I have a VPN tunnel connecting through that host, right? Arbitrary IP, this is just ICMP now, right? And I can run any other service through to that network now and touch anything on that network. Of course, coming back, I'd have to deal with routes and things like that, but that goes into network engineering and just figuring out how to get traffic to flow. But right now, we have a fully established IP connectivity between the two. So, awesome sauce. All right, I am only slightly ahead of schedule. So how do we keep this from happening, right? This is like bad stuff, depending on your perspective. And so we have this ability here. We have allow TCP forwarding, which is enabled by default, right? And clearly, we leverage that in several different scenarios today. We can change that to no on the systems that we manage, right? And very easily to do to change, because the good thing about Linux is things are just text files. You guys are good at PowerShell, so it's very easy to go figure out in an enterprise who has that configured, right? Gateway ports. I jumped over gateway ports in the demo. I didn't use it directly, but I talked about it initially. Gateway ports is where if it's disabled by default, when I create either a local or a reverse port forward, the bind address is going to be localhost rather than the actual IP address of the machine. If I change that to yes, I can bind the -L or the -R, reverse and local port forwarding, to the real IP of the interface on the network, and then other hosts can leverage the local or reverse port forward as well, right? And that's like double next level nerdiness in the fact that we can then pretty much get any system have TCP access through. And that doesn't require, well, conceivably, yeah, that does require changing this. So you will need escalated privileges to make that happen on some host. If you own the host that you can deploy on the remote network, the Azure VM, like maybe you have the ability to create VMs, but you don't have control of the NSG. You can do whatever you want now, right? Permit tunnel is default no, but I changed it to yes. I showed you guys where to do that in the demos. But there's some additional things that we can do. Maybe you do have a jump box or something like that you want to leverage. We can use this concept called match in the daemon configuration to control who has access to what. So I can say match group, no port forwarding. Maybe that's a local Linux group on the VM that we're working with, and say allow TCP forwarding no, just for the members of that group, and everybody else can do it. Or I can do something like this on a user and say gateway ports yes for me, just for me when I log in, which is valuable because then I can kind of craft this a little better than just having it be wild, wild west. Yes, yeah, but you can do, I'm trying to think, I know I presented on this if I did it last year. Yeah, I did it last year. In the demos last year, I did PowerShell remoting with Active Directory authentication. The groups that are in AD will, depending on how you set up the group the authentication for the localhost, will be represented as POSIX Unix groups. So you can have, this can be an AD group if you do the SSHD config that I covered last year in the 2018 stuff, and that's all online in YouTube. Right, but so the comment is, or the question is, why is it a bad thing if I can authenticate to these hosts but have network connectivity to services, right? Is that the question? Well, we can. So the question or the comment is differentiate. I guess the real thing is, how do we differentiate between authentication and authorization? Just because you can log in doesn't mean you should be able to do these things, right? And so in this case, we just authenticate it, and there's really no policy around the things that we can do, and that's kind of why I'm taking advantage of that. Yeah, and you have no insight into what's going on because all you see is encrypted traffic flowing. It's kind of
and they're logged in as you.
Right. When I managed networks for a living back in the day, like the nightmare scenario. You guys remember MRTG, right? And you ever see like that outbound flow of internet traffic? You're like, wow, what was that big surge of traffic that just left the network, right? And this is the same exact concept. So if you go do these things, out of the box, you might have some stumbling blocks, and pretty much this is all you need to know about troubleshooting SSH. You use -V on the client side, or on the server side in SSHD config, there's a debug level that you can increase that writes to a log file. In Linux, it's varlog secure and security, depending on your distribution. On Windows, if you do this, it writes to ETW now, which lands in your event log, which is nice, depending on your perspective. And so, and then there's -V, which you can add V, up to 4 Vs and get like some really sick verbosity. But pretty much -V is going to get you what you need, and it'll tell you what goes wrong. And so when you're using -V to troubleshoot, it's going to emit numeric value like 51 or 52 on what went wrong when you logged in. Just Google that, and it's going to tell you what the actual issue was, that error code that you get. User key mismatch is always a problem. That was my problem with the multi-hop jump host. I had to debug that and just put the right key pairs in the right locations, because that was a new auth from the intermediate box for the second box when I use -J all the way through. So yeah, so double hop key placement. Host key mismatch. This is just more of a soapbox moment. If you see a host key change on a remote system, stop what you're doing and figure out why, right? It's either someone is hijacked your DNS, hijacked your remote host, or maybe an administrator did rotate the key. If that actually happened, hey, did you rotate the key? Cool, thanks. And then accept the key, right? Or make the modification to accept the new key change. This is another stumbling block that's common when you're using keyless authentication on both Windows and Linux SSH daemons. They implement a thing called strict modes, which requires a certain permission set on your keys, and also that config file, the .ssh config file where I was storing the aliases. So if you create that file out of the box, it's going to have the wrong permission set based on the UMask on Linux and on Windows. So you have to go adjust these things. Question? True, yeah, because on Windows, I have a blog post about this about a year and a half ago. Yeah, you have to disable inheritance on the parent folder for it to work in the subdirectories. Thank you. And so yeah, these are the common sticking points. And so if you start doing this stuff and you're like, why doesn't this work? -V on the client side. If that doesn't really emit the problem that you want, go to or adjust on the server side, debug level, and then kind of walk down that path. So how are we doing on time? Okay, I will go through this slide really, really slowly. Did you guys ever see, what's that movie at the DMV where it's the sloths? Oh, gosh. I love that. Zootopia. So we covered some backgrounds and basics, just kind of get the plumbing. I do strongly encourage you to watch the stuff last year, but this kind of stands alone. But if you want to get into the internals of like forking and things like that I talked about, I covered it in pretty good detail last year. We talked about accessing remote resources with these different techniques, right? At the application level with dynamic port forwarding, an arbitrary TCP service bidirectionally, and local and reverse port forwarding. And you guys can leverage that pretty easily. We have multi-hop jump hosts, and then PWSH because I had to, but it was pretty cool to be able to see that slide all the way through with no boundaries there, because you can't do that in Windows, right? So, or you can make it happen, but it's like a total pain in the butt, right? And accessing remote networks of SSH VPNs. And then controlling and preventing things. So I have lots more data. I have some Pluralsight courses. I'll have some free cards up here for you guys to get access to these things, but I cover this a little bit in those 2 sessions. If you're new to Linux, this is a good place to start with file permissions and SCP and things like that, and last year's videos are great. And so not that I'm trying to sell you stuff, I'll literally give you free cards so you can get access to this content for free on Pluralsight if you want to come up and grab a card. There's my contact info. If you have any questions, please feel free to ask and follow me on Twitter. You hit me either up on Twitter or on email, and I'd love to give you any help. There's some conference evals in the app. 5 stars, please, come on. Right? If you don't, I'm really good with computers. So, but thank you everybody for coming. I appreciate it.